Hi, I'm Danielle, and today we're talking about A/B testing. So I currently work at a small startup based in Boston called Nift. And before joining Nift, I had never written an A/B test. I heard about A/B tests. More specifically, I heard about all the difficulties of writing A/B tests. I heard that they took too much time to write, they made your code base messy, they were difficult to remove, and especially difficult to update. Basically, all the upkeep was just frustrating. And we've ran into a lot of these issues as well. But I think over time, we've been able to develop a system that made A/B tests quick to add, easy to keep track of, easy to update, easy to remove, as well as kept our code base clean. And my goal today is to show you this system that hopefully that you can apply to your own apps, whether those are large apps that serve millions or just your own personal projects. So before diving into some code, let's define a few things. First of all, A/B testing is really just comparing two or more versions of things to see which one is the better performing version. And to do that comparison, we need an idea of what success looks like. We need a metric to track. And that metric can be anything from site engagement, where you care about likes and page visits because you want your users to be actually engaged with your website. It could be something like redemptions and purchases, because if you have a store, clearly you care about how much is being bought. It can even be things that aren't on your website, like email clicks and opens. Like are customers actually paying attention to you? And it can also sometimes be positive reviews. Like if you can get reliable review from someone else, like from off of your website, you can use that to see, do people enjoy using your website? Do people actually find you useful? So I built a quick demo app, and it's kind of like a bakery marketplace. And chefs can go there and just post desserts that they're willing to sell, and people can go and buy them. And we're going to focus on two simple A/B tests. First of all, let's see if changing the color of our call to action buttons makes a difference. Right now we have these nice little yellow buttons, and let's see if changing it to a vibrant pink will encourage people to buy more. And as our next A/B test, let's try adding a featured dessert section to our desserts list page. Okay, so now that we know what we want to test, let's dive in and see what it looks like. So the first A/B test we want to try is with our call to action buttons. 50% of our users are going to still have the yellow call to action buttons, and the other 50% of our users are instead going to see a pink call to action button. The simplest thing we can do here is to use a random number generator to randomly select either 0 or 1 to help us decide if we're going to show our yellow call to action button, which is our control, or show our pink call to action button. However, right now we have a problem with our A/B test. It's not deterministic for the user. That is, every time we refresh the page, the user has a 50% chance of seeing a different button. We want our user to consistently see the same button. The nice thing about the random class is that it takes a number as a seed for input. That is, if you consistently pass the same number, it will always generate the same sequence of random numbers. So we could take advantage of this for our user. If we pass in the user ID, that same user will always see the same color button. Great, so now that we have a pretty consistent test, we can copy over this code to our other two call to action buttons. So now let's add our second A/B test. On the desserts list page, we want to add a featured dessert section for half of our users. We want to see if this will help to increase engagement. So similar to the first A/B test, we're going to do a simple 50-50 split. That is, half of our users are going to see the featured section and half of them won't. Now we have a problem with test collisions because of using the same seed in both A/B tests. That is, if we get a 0, we know that we'll always see yellow CTA buttons with a featured dessert section, and if we get a 1, we know that we'll always see pink CTA buttons with no featured dessert section. The easiest thing to do is to just add a number, in this case 1, to our user ID. Now, tests will still be deterministic based on the user, but will no longer be correlated between two different tests. So right off the bat, there are a couple of problems with this code. First of all, we have a lot of duplicate code. We're essentially doing the same thing in 3 separate files. Second of all, at the beginning of this talk, I promised you that adding tests would be easy to find, easy to update, as well as easy to delete, and right now it's none of those. Also, you have to remember to give it a unique seed every time you add a new A/B test. If any of your A/B tests have the same seed, you're essentially colliding your tests, and you can't guarantee that your data means anything. Also, how are we even capturing data? Yeah, you can run through each user and see what bucket they fit into, but you have no guarantee that the user even saw any of those 3 pages. So we're going to fix this by doing 2 different things. First of all, for each A/B test, we're going to add its own experiments class. This class is going to contain all the logic for each A/B test. This means that now we have one place to update, one place to delete, and it makes it so much easier to find what files are affected by our A/B tests. Also, we're going to add an experiment events table. Every time, or at least the first time the user enters our test, we're going to log them into this table. And we're going to say not only that they're a part of this test, but also whether they're control or some other variant. So let's go back into our tests and add an experiment events table, and then add an experiment class for each A/B test. So let's start by first adding a migration for our experiment events table. In this table, we're going to add a non-null reference to the user, a non-null experiment name, and a non-null bucket or variant that the user is in. While we're at it, we're also going to add a unique index on the user ID and the experiment. There really is no reason to add more than 1 row per experiment per user because the user really only ever enters an experiment once. Now we can create a new folder to hold all of our A/B tests called experiments. Let's start adding our new experiments class. There are a couple of things we're going to be doing in this class. We're going to take in the user as an input. We're going to assign them to a bucket, one of them being control, the other being show section. We're going to track the user, that is, we're going to log the user as being a part of this experiment. And then also we're going to add a function so that we can easily ask, should we show the featured dessert section or not? Now we have a class that contains all of our A/B test logic, and all we need to do now is call it where it's needed. Now we can go back to our desserts index HTML and replace the if logic with our actual experiments class. Okay, now we're going to make another experiment class for our call to action buttons A/B test. But what if we want to modify our test now? Maybe we don't want to run it for every user anymore. Maybe we only want to run it for users that have already made a purchase. How would we make that update? It's actually surprisingly easy. So let's create a trackable function. This function is just going to determine the eligibility of the user. And basically it's just going to say if the user has orders or not. We can then use this function in track experiments. If the user is not trackable, we won't save them in the experiment events table. Also, in our show pink CTA function, we can instantly return false if the user is not trackable. Now we're ready to use this experiment in our 3 view files. If you remember at the beginning of this talk, we wanted to make sure that our tests were easy to remove. Well, because all of our logic is within our experiment class now, all we have to do is really search our code base for our class name. And except for the class definition, anywhere where we find it is basically code that's affected by our test and now can be removed. Okay, now that we have a running A/B test, let's see how we can get the results. We can easily open up a Rails console and run whatever queries we want there. We can also go straight to the DB and run queries there as well, but chances are we're going to want to check on results multiple times during the test cycle. So it makes sense to save how we get the data. And what better place to save it than in the experiments class itself? When looking at results for A/B tests, there are usually two things we care about: how many people were in the experiment and how many people converted. In our case, we count a person as being a conversion if they made an order after the experiment started. Once we have that data, we can then determine not only if one of the variants was better than the other, but even if this test was useful or significant. Okay, great. Now we have results. We know how many users passed through our test. We also know how many users actually made purchases, or in other words, how many users converted. Now, if control is better than the pink button, does that mean control is always better than the pink button? No, and this is where something called statistical significance comes into play. Statistical significance just means how certain are we that if we repeat this experiment, how confident are we that we are likely to get the same result? So this is a percentage from 0 to 100. And of course, the higher the percentage, the more confident we are in our results. So if we have a statistical significance percent of, let's say, 90, we can say we are 90% confident that control is better than the pink button. And usually when we're running A/B tests, we want like a percentage of at least 95%. That is saying we are 95% confident in our results. So the formula for calculating statistical significance is actually a little bit complicated. It uses a lookup table. So instead, we tend to use online calculators or libraries to calculate it for us. So far, we have a pretty good system. We have all of our test logic in one place. Our tests are easy to create, easy to update, and also easy to remove. How can we make it better? Well, one thing we don't support right now are multiple versions of the same A/B test. Oftentimes, when we make a new variant, we want maybe to put only about 10% of our users through that variant first. For example, if we have about 1 million users and we put 50% of those users through a new variant, if that variant does so much worse than control, let's say by about 10%, that means we could potentially have a drop-off of about 50,000 users. So oftentimes what we'll do is we'll start with a small percentage of like 5 or 10%, see if the test does okay, and then slowly bump that number up until we reach 50%. Also, right now, if we have any non-developer stakeholders, the only way they can get data is by asking a developer. Also, if we want to change a test, we have to deploy a new version of our app. If we can back our tests by a database, then we can make a user interface so that non-dev stakeholders can also see results. Finally, all of our tests so far have been on the user. That means if we wanted, for example, to make a test on categories where 50% of the categories will show a description on the dessert page, or if we wanted to make a test on orders where maybe after you create a new order, 50% of them will get a follow-up email that says, here are similar desserts. We can't do that right now. So how can we support these use cases? Well, one, we can create an experiments table. This table will allow us not only to create a UI that non-dev stakeholders can see, but it'll also allow us just to create a row anytime we want to create a new version of the same A/B test, as opposed to creating an entirely new commit and deploying the app. Finally, we can also make experiment events polymorphic. If it's polymorphic, then it doesn't just have to support users, it can support any type of model that we care about. So let's see if we can update our tests to support this. Let's first start by updating our experiment events table. I'm just going to roll back our past migration and update the migration file. First, we're going to get rid of user and add target. If you remember, we want to make target polymorphic so that we not just support users, but we can support any modeled. Next, instead of allowing experiment to be a string representing the name, we're going to actually make it a reference to the new experiments table that we're going to make next. Finally, we're going to update our index. Instead of having a unique index on experiment and user ID, we're going to want to make a unique index on the experiment ID and the target type and target ID. Just before running our migration, I realized there was a good chance that our unique index was going to have a name that was by default too long, so I'm going to manually give it a name here. Now let's add a migration for our new experiments table. Our experiments table is going to focus on 3 fields. A non-null string field, which will be the name. Next, we'll make a JSON field to represent our variants with their aspect ratios. As an example, if we wanted to run a test where we had 3 variables, one of them being control, and we wanted control to be 50% and the other 2 variants to be 25% each, we'd make a hash where control had 2 and the other 2 variants had 1. Finally, we'll add our last column, which is just the version. Like we said before, the same experiment with the same name can have multiple versions. So now that our updated experiment events table and our new experiments table is ready, let's take a moment to clean up some code and add a base experiments class. Instead of using a user, our class will instead take a target. We'll require all of our subclasses to implement an experiments and experiment method. This is just so we know how to get all of the experiments that have run for this class, as well as the current experiment that is running. We'll move our track experiment method from the subclasses to this class, since they're all doing the same thing. Essentially, adding an experiment event for the target based on the chosen experiment and the current running experiment. We'll create a default method for trackable set to true. And finally, we'll move the chosen experiment method from the subclasses to the base class. When you think about it, we essentially have everything we need to calculate this here, since it's all saved on the model. We'll update our random number generator in our chosen experiment to use a seed that's based on the class name. This way, every time we add a new A/B test, we don't have to figure out what seed we haven't used yet. Finally, we'll use our variance and aspect ratio hash on the experiment model to figure out which variant our random number is pointing to. Each number in our variant hash is essentially the size of a range. If we stack those ranges on top of each other numerically, we can guarantee that our random number will fit in exactly one of them. Now we're finally ready to update our two A/B test experiment classes. Let's start with our CTA buttons experiment class. First, we'll extend from our base experiment. We'll remove our attribute reader, instead add an alias method because we're going to start using target instead of user. We'll remove our experiment started at because now we can just get that directly from the experiment model. And we'll start to add our experiments and experiment methods. As we create our experiment method, we'll also use it as a way to lazily load our first version. We'll give this version the name initial, and we'll also run our test as a 90-10% split. That is, we want control to take 90% of our users. Now we can update our print results functions. Because we have multiple versions for experiments, we'll want to go through all of our experiments to get the versions as well as the different variants on the versions. Here I'm using the variants that are hard-coded in the print results function, but I could have just as easily used the variants that are on the experiments model. Because we no longer have user ID, but instead have target, which is polymorphic, we'll have to approach this query in a different way. It's a little difficult to do polymorphic joins, so instead we'll do a join from the user perspective to experiment events and orders. We'll also write our query to get the number of users that converted in a similar way to how we got our totals. We'll instead start with the user, join to experiment events and orders. And finally, instead of using experiment started at, we'll just use the created at on the experiment model. Finally, we'll update our featured desserts experiment in a similar way to how we updated our CTA buttons experiment. We'll remove our attribute reader on the user. Instead, we'll add an alias method to target. We'll allow our super method to handle initialization. We'll add experiments and experiment method, very similar to the CTA experiment methods. And we'll also remove chosen experiment and track experiment from the class. So at this point, I'd say we have a pretty flexible system. If we wanted to, we could back a UI for non-developer stakeholders. We could easily create, update, and remove A/B tests in less than 5 minutes. And maybe more importantly, we have a great opportunity now to find out more about our users. I hope that by the end of this talk that you see that A/B tests don't have to be scary or annoying, but instead I hope that you have now confidence to try them out in your own projects. If you have any questions or comments for me, I'll be available in the RailsConf Discord. Thank you.